Alright, this is just another simple video. We're going over the double angle formulas for sine and cosine, very important formulas. And hopefully, as I foreshadowed in the video where I went over the angle sum formulas for sine and cosine, how you could actually get the double angle formulas. Hint, double angle, think about it. Sine of 2 theta. Isn't that just the same as sine of theta plus theta, right? These are equivalent. Same with cosine of 2 theta. Isn't this the same as cosine of theta plus theta? I think so, right? 1 plus 1 equals 2. Theta plus theta equals 2 theta. So now we're literally just applying angle sum formula here. So let's do sine. So sine of theta plus theta. Again, please watch the video where I go over the angle sum formulas for sine and cosine. Without it, then you're just going to have to be memorizing stuff. So highly recommend you watch that. And memorizing is terrible. Understand. You'll still have to remember stuff, especially if you're on a strict time, strict time limit. But it's good to at least have that peace of mind that you know where this comes from. And of course, if you have unlimited time, you can just prove the things. A lot of these proofs are meant to be pretty short. Not always, though. But I hope, for the most part, they will be pretty short. Not necessarily easy or simple, but short. So she'll then be sine of theta cosine of theta plus cosine of theta sine theta. And then here I'm just going to use a commutative property and change this term to just, of course, let me write this, sine of theta, cosine of theta, and then plus sine of theta, cosine of theta. And hopefully you realize that these are the exact same thing. So it's just 2 sine theta, cosine theta. So we can say, therefore, sine of 2 theta equals to 2 sine theta cosine theta. Great. Now for cosine. Cosine of 2 theta, or theta plus theta, equals cosine theta sine theta minus, cosine theta minus sine theta. Okay, and of course this will then just be cosine squared of theta minus sine squared of theta. So therefore, cosine of 2 theta equals cosine squared of theta minus sine squared of theta. So I know, very fast video, but I just want to point out one other thing here. And again, the reason why I'm pointing it out is because when you do integral calculus, there's a certain variation of the cosine double angle identity that may help you, especially if you don't know integration by parts. And of course, I used it in the video where I proved area of a circle, right? So it goes back to the Pythagorean identities. And again, I made a video like a long time ago on the Pythagorean identities, so make sure you watch that if you don't understand them and you're forced to memorize them. So we want to get this cosine of 2 theta here in terms of cosine. Now, we have a sine squared theta here. Now, of course, going back to our Pythagorean identities here, we know that sine squared of theta plus cosine squared of theta equals 1. So we want to isolate the sine squared of theta here. So then we'll get sine squared of theta equals to 1 minus cosine squared of theta. So we got something in terms of sine, in terms of cosine. So that's why cosine of 2 theta can also equal to cosine squared of theta minus 1 minus cosine squared of theta. So then it'll be cosine squared of theta minus 1 plus cosine squared of theta. So then that'll be 2 cosine squared of theta minus 1. So this is another variation right here. Again, I'm just going to kind of foreshadow this. If you want to find the integral of the indefinite integral of cosine squared of theta d theta, use this identity is what I'd recommend, or integration by parts, which would just be cosine theta d theta. Do your ultraviolet voodoo or tabular or whatever it is from there. So yeah, pretty simple. See you guys in the next one.